All right, good morning, everybody. Welcome to the second Drainage and Donuts webinar. We're going to get started in just a second. We're getting our getting everything together. Looks like Matt, if you could just let us know when you're ready.
I'm ready.
All right, okay. I'm going to do a quick introduction to our webinar series, and then I'm going to turn it over to you.
All right.
All right, thank you. All right, everyone. Well, welcome this morning to, there we go, to the second webinar in our Drainage and Donuts webinar series. Just quickly for everybody that wasn't on the webinar on Wednesday, this webinar series is funded through the Northeast Extension Risk Management and Education Program. Our goals for the webinar are for everyone to learn about best management practices on tile drained fields, learn how farmland with subsurface tile drainage may affect water quality, learn about end of tile treatments, and to overall increase your knowledge about the required agricultural practices and new agricultural practices that will be going into place to manage subsurface tile drainage. Just quickly, this is the second presentation in our series. We'll have also 3 more presentations, 2 next week and 1 the following week. For each webinar that you attend, you can receive 1 CCA credit and 1 water quality education credit. At least for those folks in Vermont, you will need water quality education credits to meet the RAP standards. If you didn't register online, then you can just simply email Susan Brulette with your name, farm name, location, and CCA credit, CCA number if applicable, and she'll make sure you get the credits that you need. All right, so now I'm going to turn this over to our guest speaker, Matt Ruark from the University of Wisconsin. And Matt has done quite a bit of work with subsurface tile drainage on farms in Wisconsin, and he actually presented to us a few years ago, and I asked if he would come back and make a similar presentation this time to let us know what's happening with tile drainage in Wisconsin. So thanks, Matt. I know it's an hour earlier there, so appreciate you getting online. We'll make sure you get a donut too.
Yeah, I didn't leave early enough. I feel like I should be eating a donut.
I know. All right, I'm going to turn it over to you. And folks, remember, you can type your questions in the chat box, and we'll make sure there's some time at the end to get those answered. All right, Matt.
Cool. And just to double check, you can see my slides.
Yes, sir, we can.
All right.
Thank you.
So thanks, Heather. I appreciate it. Yeah, we do a lot of work in Wisconsin with tile drainage, especially as it relates to our dairy production systems. And so, you know, pretty general title of presentation here, tile drainage management in Wisconsin. So we have a lot of collaborators in the research on this, and I want to make sure they're acknowledged. We have a lot of different people, a lot of different groups working on it. So what I thought about today is just review the tile drainage, cropping systems, and soils of Wisconsin, just to put some of this stuff in context, and then you can think about how it relates to your soils or regions in Vermont. I want to discuss our ongoing efforts with field level measurements. So what we have are actual edge of field monitoring stations. So we're participating with farmers, and we're measuring the actual runoff and tile drainage from farm fields. I want to talk a little bit about, and then we'll scatter in some kind of recommendations for best management practices, and then share some data too. I don't want to make it too data heavy and get a little boring. Try to make it as entertaining as possible. So with that, yeah, I highly encourage, if anyone has any questions, make sure you type them in. Stop me. I want to make sure everyone gets the most out of this. So sometimes I just kind of go flying through some of this stuff, but there's a lot of detail in here. So yeah, I'm always happy to stop and answer questions. All right, so let's start with, in Wisconsin, it's the confluence of many things that drives this. It's dairy, it's tile drainage, and it's landscape, and it's watersheds. So, you know, we look at where the dairy cows are in the United States. We've got, let me use, so we've got, you know, in Wisconsin, a lot of cows. Vermont's got a lot of cows, so we have a lot of manure, right? When you look in Wisconsin, where those CAFOs are, or where the most intense dairy production is, we're going to focus in on the eastern side of the state here. And so this is an important region. So it's a lot of dairy and a lot of other things. So when we look at where the tile drainage is in the Midwest, now Wisconsin's a little bit different than, a little bit different, right? Okay, so we're a little bit different than our neighboring states. So if we think about southern Minnesota through Iowa, Illinois, Indiana, and Ohio, the tile drainage, you know, kind of that tile drainage belt, is pretty similar. They're mollisols, grid, you know, or the grid lined tile drains. We don't have that as much in Wisconsin, but we do have, excuse me, a lot of drainage in the eastern side of the state. That's gonna be over here. And so, but we don't have as much as other states. But when you think about where the cows are on the eastern side versus where our tile drainage is, right, those things kind of overlay with each other. And then we think about our soils, and we have on the eastern side of the state, in what's in the red here, these are our, we call our red clay tills. So these are our heavy clay soils. And so we want to drain these just to kind of alleviate some of that that water holding, but they're really, really tight clay soils as well. And then we link that up with the fact that it's in the Lake Michigan basin. So the western, you know, 2/3 of Wisconsin, water flows into the Gulf of Mexico, the or Mississippi River basin, right? And then the eastern side flows to Lake Michigan. So it's the water quality issues there affect lake water quality, right? So that's going to mostly focus on, it's going to focus some on nitrogen, but primarily phosphorus. While the western side of the state, Mississippi River basin, Gulf of Mexico, we're generally concerned about nitrogen. So so it's this confluence of all these things kind of stacking up on each other that puts a lot of pressure on it. And just kind of delve in a little bit more into the soils here and why we tile drain them on this eastern side of the state. It's because we have this fine glacial subsurface material. So the water is just held there. And so as opposed to having maybe what would be considered a perched water table where we just want to drop the water table, we really want to, this is really more of a true drain. You know, we want to drain the soil, want to help it dry out. So free draining up here, not so much here. So we want to help it. Okay, so when and I apologize, I don't know who the other speakers are in this seminar series, but a lot of other states have what we call plot level tile drainage research experiments set up, where they've got a nice experiment station where they can intensively monitor tile drains on a small scale and be very controlled. So in Wisconsin, we don't have that. In Wisconsin, so to kind of alleviate that or try to overcome that, we have something called the UW Discovery Farms program, or Discovery Farms. And here we work with farmers. We have many different studies related to watershed level studies, tile drainage monitoring. We monitor nitrogen use efficiency. But it's these two things here, the tile drainage monitoring and the edge of field monitoring, where we put most of our effort. And so we have farmers that have agreed to participate, and we rig up their fields and monitor and measure the runoff coming off the field, and also the water and nutrients coming through their tile drains. And so it's continual monitoring. So we don't have sort of a classic experimental design where we have a direct comparison that's really controlled. We have a lot of samples, and we have a lot of measurements and monitoring, and then over time, then we can evaluate trends in the data. So it takes us a long time to make recommendations because we have to accumulate a lot of data. But we do have a lot of data. And for those that are interested, so we work with the USGS, and we set up, so in the middle here, you can see this is the surface water flumes that we put in to kind of collect all the water as it runs off a field. And then on the bottom center here, we see this is where we basically dig in, tap into the tile drain itself, and monitor flow and measure the water coming through there. So very intensively monitored, high level of scientific quality, and it produces a really interesting data set. And so, and we'll scatter some of that data in throughout. So for the tile drain, we have a lot of fields where we measure surface water. We have 3 fields where we have intensively sampled the tile drain over time. And just as a little promotion, we've restarted a bunch of tile drainage analysis that we haven't included in this. So maybe invite us back in a few years too, and we'll have a bunch of updated data to share. But we've got 3 sites, and we've monitored probably 4 to 5 years per site. So we have a lot of site years worth of data. Now what's interesting is they represent different things. So we're gonna just for the nomenclature, A, B, and C, and it's north to south, A, B, and C. So the one thing is that when we're working with these farmers, they all have different tiles. One has a ceramic tile, one has a cement tile, and one has a PVC tile. So we have all the different, we have many different types of tiles that are out there, and that's going to just depend on the age of the system, when it was installed. And we'll talk a little bit more about that. And then kind of the placement of it, where this farmer put their tile under a grass waterway in the field, and they're a grain cropping system that also uses animal manure. The second one is a random tile, so it's just put into like random spots where they felt drainage could be improved, and they graze that land. And then the last one, the most southern one, is a pattern tile, where it's a little more structured with a little bit of randomness to it, but it's under no-till production, and it receives manure every other year. So you can see, we've got all these different types of systems and different types of tiles as well. So what we've done in Wisconsin, and I'll have a link to this at the end, is we have 3 extension publications that the first one is understanding and locating your tile drainage system. So we feel that's always the first step when people want to talk about tile drainage. Unless you've had it done very recently, there's probably some work that probably needs to be done in figuring out exactly where your system is. We've been installing tile drains in Wisconsin for probably, over 100 years. So depends on how good the record keeping was. Oh, looks like I put understanding in twice. The other one, the second one is maintaining them. So the first part is understanding them, and the second part is maintaining them and all the things you want to do to make sure that it's functioning properly. And then the third one is managing tile drains to prevent nutrient loss. And here we provide some recommendations for their use, or for nutrient management or nutrient use on tile drains. And I'm going to focus pretty heavily on liquid dairy manure applications. So I think that's probably going to apply to a lot of you listening today. All right, so we've got this list of best management practices. So let's start with the first 2, understanding the tile system features and maintain the drainage system. So obviously the first thing we need to do is actually understand the system before we can attempt to control it. So again, this is a lot of these is detailed in our first publication here. But really there's 2 main things that we need to be found and understood. One is the air vent, and the second is the tile outlet. So everyone should know where their outlets are and where they're draining into. And we want to also know where there is an air vent to allow to allow air to move in so the water can flow out. Otherwise it creates, there'd be the back pressure, the tile wouldn't be functioning properly. Okay, so a couple things with that. Know where your air vent is. Make sure you're not applying manure around it or near it, because that's actually a direct conduit. Make sure it's not clogged. Make sure it's functioning properly. Second thing, tile outlets. Make sure they're not clogged. Make sure they're functioning properly. The tile outlet is going to tell you a lot about what's going on in the system. So knowing where they're at and making sure they're free flowing will also give you the opportunity to observe it over time and check out what's going on. So we've got, if you don't know where your tile drains are, we've got a couple recommendations. So we've we've got some tips on how to identify the tiles. Really, we've got 8 different things here that we've either come up with ourselves, but most of them are what we've worked with, input from farmers that have noticed this, or the tile drain installers. So there's some nice rules of thumb. What this really comes down to is that soil, when it's bare soil conditions, soil will be drier under, right over the tile drains. And when crops are growing, crops tend to do a little bit better right over the tile drain. And so the reason for this is, so you have the tile drain, and then you have the spacings between the tile drain and the water table. So the water table, when the tiles aren't flowing, look like this. But when the rain comes in, above the drain drains first, and so it'll sort of help prevent saturated conditions right over the drain. And so we have some pictures of what that looks like. So here's a nice photo of course, I'm only showing photos of things that are clearly shown here, right? So it may not always show up in your field, but one thing to look for is these really dry conditions, so you can really make out where the tile drains probably have been installed in this field under under bare soil conditions. You can pick that up. And then under, we've got some growing alfalfa. You can pick it up where it's just a little bit taller. You can kind of see this kind of bump in biomass right over where it is. It can be subtle. This is one of the more obvious examples, but that right over it, because the water drains out, those roots just aren't being choked out by water for as long of a time period. So it just gives it that little bit of bump where you can kind of pick it up. So that's one way to do it. The other way to do it is to find some imagery. So a lot of times, depending on the pictures and when they were taken, you can actually maybe find it from the NRCS Web Soil Survey. So on some fields, if pictures were taken under the right conditions, you could pick up where they are, like on the left. On the right is some infrared aerial photographs, which can be taken, and you can pick that. Those definitely will pick up tile drains. So there's ways to do it, or just other types of satellite imagery. Again, it depends on when the sample or the pictures were taken, but maybe just even on Google Maps or Google Earth, you could find some of this stuff. I mean, these are prime examples of clearly you can find where these tile drains are. In any case, so there may be some things that you need to do. Hopefully there's some good record keeping, and but that's always the first thing we recommend, is figure out where they are. And then you can start to think about them and think about your management in relation to where these drains are. Okay, so in Wisconsin, it's been kind of interesting. So since 2008, so we had a lot of flooding in 2008, and tile drainage really has even taken off a lot since then. So even in the past 10 years, the tile drain installers that we've worked with and communicated with have been working nonstop. Now, a lot of that could be just replacing old tile, but we do believe that there's a lot of new tile going in. Now, most of the new tile that are going to get put in are most likely patterned. And so that means that it's set up on a nice grid, nice and organized, rather than it being a bit random in the fields. So if there is random tile, which we're saying it's just kind of a line put in just some direction, it's mostly going to be put in a depressional area. So it's going to follow the topography. So rather than compared to the rest of the Midwest, where it's a little bit flatter of a landscape, where they're going to put in pattern tile pretty consistently, and then that'll flow into a drainage ditch. We have a little of that in Wisconsin, but and my guess the new tiles are put in are going to be like that, but there's still a fair amount of topography, and so it might just be a tile go in that direction, a tile go in that direction, just based on the landscape. So there's some things to think about when you're looking at your field and you think about how old the system is. Maybe if it's older, don't expect to find a nice pattern grid, grid type setup. So, okay, so know where it is, know your features, know where the things are. And And then the next big thing is let's start thinking about your manure. And so it's going to be about the manure timing and placement. So number 3, assess the soil conditions prior to manure application. So there's one thing here. So we don't want the soil too wet. We don't want the soil too dry either. And I'll explain a little bit more of that as we go on. The other thing is to check the weather forecast prior to application. You know, that's a big thing. If as much as we can predict the weather, obviously, if you're going to put out your manure and it's going to be a big rainstorm the next day, you know, that's going to move things down into the tile drain. So if we can try to avoid if there's a big storm with, you know, coming maybe within 48 hours. Want to monitor the tile drainage outlets when applying manure. And so that relates to 2 things. One is if the tile drains are actively flowing, that means that there's still a connection between the water in the soil horizon and the tile drain. So if it's flowing, it's still moving, the water's still moving through the soil. So applying manure, if that manure can interact with that draining water, it's going to move it out. So it's going to, you know, it's going to cause more losses. So we don't want the tiles to be flowing, but also then there's some things we can do when we can look at the tile drain after you've applied manure to kind of evaluate, was that a risky time or not? And then, so I'm not going to talk a lot today about the engineering technologies at the end of the tile line, but for those that have that, if you can control your drainage, restricting drainage prior to manure application, or maybe even a little bit after, might be beneficial. Of course, that's always going to depend on the conditions. So here we go. We've got a second fact sheet on maintaining the drainage systems, and then our third one is on the managing tile drains landscape to prevent losses. So let's talk about the big issue of maintenance and why it's important. So the biggest issue that we face is what we call blowouts. And so we start here on the left. If there's some sort of weak point in the drain, and there is back pressure created in the tile. So usually this comes with the inflow. There's some sort of pressure or blockage happening in the drain where the water's can't freely form out or freely flow out. There's a weak spot in the drain. The pressure builds up in the drain itself, finds a weak spot in the drain, and then causes that drain to rupture. So actually the water then starts to push upward. So the water's trying to find a way out, so to alleviate the pressure. And then as we go on the right here, it reaches the surface, and we got this void in the soil. And then what we have are these sinkholes. And so then what happens here is if these are created, that is a direct conduit, right, into the tile drain. So we want to avoid those happening. So proper outflow and good ventilated inflow are the keys to preventing this. So here's a picture of a blowout with water actually flowing up through that hole that was created. And then here's a picture at the end, or a different, I think this is a different field, but where the water is now flowing into a hole after a rainfall event. So anyway, so it's just these are really big problems. And you can imagine if you're putting manure out there, then you've got this direct transport of manure right into the tile drain. So what we want to happen with manure is we want that manure obviously to interact with as much soil as possible, for that soil to filter out a lot of stuff, or at least, let all those biological processes take place to convert the nitrogen or to remove some of the pathogens. So, but if it's getting right into the tile drain, then it doesn't have a chance to do that. So then we have the other recommendations is looking at the outflow. Don't apply when the manure, don't apply manure when the drain is actively running. Check the drain outlets for obstruction. And then here's a picture I took from a e-extension article. Observe the condition of the water discharging. And so what you're looking for is froth. So the one on the left, that's nice, clean water coming out, not very frothy. The one on the right is frothy. So what makes it frothy is organic material. And so it doesn't necessarily have to be manure, but depending on when you applied manure, and if the tile drain comes out frothy, probably is an indicator that the manure was, moved directly into the tile drain in some way. So that's a really nice indicator to think about drainage performance and also nutrient management. All right, so then here's a little bit of data, and what we realized is when we've got these three farms, Farm A, Farm B, and Farm C, and they all have different management practices, and they all have different, slightly different drainage systems, and they all act differently. And so that's going to be one of the bigger themes, is that everyone needs to understand their drainage system on their field and understand that well. So we have some rule, some standardization where Farm A so Farm A is in blue, Farm B is in red, and this is the daily flow. And you can see, so we started in November of 2004. We're going to go to September of 2009. So most of it is winter-based flow. We got rain, we got snow melt that's happening over the winter. And so we have these peak flow events, not a lot of flow in the summer. And so we have this nice seasonal relationship of this, of winter, and basically winter to early spring are times of peak discharge. Except then, of course, Farm C, this is the no-till field, just had different patterns. We saw almost continual flow over that time period. There wasn't that tile was continuously flowing. Okay, so what does that mean if the tile is continuously flowing? It means that it's trying to drain. It was put in too deep, so it's trying to drain at a level that the influx of water is faster than the outflow of water. So you could think about it's put too deep into the water table. So it's trying to drain as best it can, but it's at some level it's not really helping. So that means that to some extent there's always kind of a conduit between the water or the manure that enters and the water that leaves. So this field is a special case. If you have a field that is continuously flowing, I don't know if I have a specific recommendation, but you want to be more careful on those fields, or think about reinvesting in a drainage system. So when we think about drain flow and the relationship between tile drainage and surface runoff, so typically when we talk about it, tile drainage, fields that have tile drainage are generally have a positive effect on surface water quality, right? So if we can get if drainage helps soil dry out, rainfall is more likely to go into the soil profile than run off. But there's also a very specific relationship between tile flow and surface flow. And so what you can see here is, so in the blue we'll start with the red. So the red, so we have all these drainage events. And so we've got the red being these tile flow events. And so what you can see is, when the tile's flowing, not all tile flow events occurred with surface flow events, right? So, of the 5 tile flow events, only 3 of them had concurrent surface flow events. What's also interesting is that the tile flow happens first. So if tiles are flowing, that means there's a lot of water has been built up, and so it's not until after tiles start to flow does surface runoff actually start to occur. If we look a little bit deeper into some data, we've got these rainfall events in blue, and we have these this is the tile flow, so trickling down, a rainfall event, it picks up and then starts to decrease over the course of the event. There is a maximum capacity, right, for those tiles to flow. So it's also interesting that it's not until the tile flow reaches maximum capacity that surface flow starts to occur. So there's always a little delay, but then right when it hits that peak capacity, that's when the surface flow starts to occur. So generally speaking, tile drainage is positive for surface water quality. And there we're looking primarily at reducing some erosion issues. But obviously we've created now this thing where most of the water then can be exported through subsurface, and we can move a lot of things with it. I'm gonna skip through that. Well, I guess the one thing on this is just if you're interested, and it's a little bit difficult to assess, but what percent of the amount of rainfall that occurs, what percent leaves the field from drainage or tile flow? And so in a lot of cases, we're looking between 35 to 20% of the total rainfall is exported through surface or tile, and anywhere between we calculate 16 to 24% of the rainfall is moved. So it's not all of the water, right? So there's still water that's retained in the system for sure, or actually percolated past the tile drain, but it does move about a quarter of the rainfall from the field. So then next what else can we do? So we can use tillage to break up preferential flow paths prior to or concurrent with application. We want to take precaution when applying liquid manure under no-till or perennial crops. And then we want to watch out for surface inlet. So anything that is a direct pathway, which obviously the surface inlet is, but also what we're going to call preferential flow paths, or big cracks in the soil or natural cracks in the soil, or root channels, right? With no-till or perennial crops, we've got a lot of roots going through the ground. We haven't broken up the structure of the soil. So the soil is a little better structure, but that means it could be more porous. And so this is just a nice picture of an example of what can happen, right? Is that, so we took some dye and we put it on the soil, and you can see where it kind of follows. This is a bit of a plow pan, moves a little bit laterally and then finds these cracks in the soil, right? So when you apply something, you can think about the blue also representing manure. It doesn't just move nice and filtered all the way through the soil. Part of it finds those cracks in the soil and moves through the cracks, right? And then so it depends on, it's a field to field kind of assessment of how, what's the risk in terms of cracking. Our soils in eastern Wisconsin are heavy clay soils, or heavier clay soils, and thus are more likely to have these kind of big, what we're calling macro pores or preferential flow paths. And so here's a picture of some cracking in the soil surface. So we talked about we don't want the soil too wet when we're applying manure, but we don't want the soil too dry either, because then there's definitely these cracks in the soil. The manure is going to move right through. So what do we do, especially when it dries out a little bit? Those cracks they open up a little bit. So what can we do? And so one of the biggest recommendations to alleviate this is, when injecting manure, to use some sort of sweep injector that can, for lack of a better term, smear over those preferential pathways, right? So if you have knife injection, it tends to be a bit more of a point injection. And if you're doing that in an area where there's a crack or pathway right underneath, it can move right through. So one of our recommendations is, if you have a sweep injector where it's kind of smearing over the top of those cracks, it can help reduce the amount that's going to be moved down through one of those preferential pathways, just by kind of blocking it off or kind of smearing it over. Doesn't completely prevent it, but it's a technique to alleviate that. But again, these are really going to be only beneficial on soils where you feel there are a lot of preferential flow pathways. So we think more about nitrogen and phosphorus loss, and we want to, how much are we losing? We're losing quite a bit of nitrogen in our systems here. Farm A was the chisel plowed grain system. Farm B was the grazed paddock, and Farm C is the no-till field. We're seeing most of our nitrogen loss occur through the tile drain relative to the surface, and in the case of the annual cropping systems, we're averaging either 34 pounds of nitrogen or 62 pounds of nitrogen. Interesting, this farm field, this has been corn every year, or this was, this had manure applied every year, and this field had manure applied every other year. So it's kind of interesting. It's exactly half. So that's a lot of nitrogen to lose. Well, one, from an environmental standpoint of when it reaches the surface waters, what's happening, and the second one is I can't go backwards here. All right, and the second is, I don't know, I'd like to capture that nitrogen back in our system. 34 pounds, 62 and 34 pounds of nitrogen, it's a lot of, there's some economic value to that nitrogen as well. So how can we alleviate that? The other thing, I quantified the total losses here, and there's 3 messages that I want to create. So we have got the losses in pounds per acre from the tile and from the surface across 3 years. We've got the total nitrogen loss, and then we have broken out into either nitrate, and so nitrate's going to be the nitrogen that's in the water. So that's the form of nitrogen that's in the water. We have ammonium, which can also exist in the water, but we tend to think of ammonium also as can bind to soils and clay contents. We don't think about it as, it shouldn't be as mobile as nitrate. And then lastly, we have organic nitrogen. So that's nitrogen that's still in an organic form and hasn't been mineralized into a plant available form yet. So the first thing is, in one of the years, we reported an average, but in reality, one of the years we lost almost 100 pounds of nitrogen. That's a lot, right? I think we can all agree. So even if in some years, the first year we only lost 14, the second year we lost 35. So there are confluences of it. There's situations where there's events that occur, they're going to cause huge losses. And so, and we'll go through a little bit of that, but it's really connected to the timing of manure relative to the timing of rainfall. So trying to manage as best you can to avoid that risk is the biggest issue that we're trying to figure out. We always get stuck, though, don't we, with when we can apply manure. Once we have, we need to get manure applied at certain times, but know that there is risk. The second is, sometimes we can lose a lot of ammonium, and this is quite interesting. All right, I'm sorry, that was the last one, tile. This is when we lose nitrogen in the surface, we lose it as ammonium or organic nitrogen. We don't see a lot of movement of nitrate, right? And that's really because when we're losing nitrogen in the surface, we're losing it as it's connected to the soil. So it's still going to be as organic nitrogen, basically the organic matter that you've lost, or in the ammonium form, the stuff that's bound to the clay particles. But also know that depending on the timing of application of manure, you can actually lose some amount as ammonium itself, which means it hasn't even had time to get microbially converted from ammonium to nitrate. And so this is a situation where I don't know, what is this, a purple in the ammonium here? You can see we have this big spike in ammonium concentration in the drainage. It was right after manure was applied and a rainfall event happened. So that shows you how quickly the manure can be transported to the tile drain. It doesn't even get a chance to get converted. The microbes don't even have a chance to get at it because the water flushed it through. As we go to this, we think about this, we lost 100 pounds of nitrogen. It didn't all happen in one event. But, with farmers that are doing multiple, this was a case where there was multiple manure applications, and it was just manure application, rainfall event, manure application, rainfall event. We use this to highlight that there is risk. A farmer in the first year could be doing great, next year be doing absolutely terrible, right? With the same philosophical approach to management. So we already kind of covered that. So then the last thing I want to cover here at the end is phosphorus. So we think about phosphorus as primarily we lose phosphorus through surface movement of water or erosion. But in Wisconsin, and other places, we're seeing actually a fair amount of phosphorus loss through the tile drains. And so the first thing is that all of these fields have manure either annually or every other year, and then this is a grazed pasture, so there's cows on it all the time. So we have very high. We use the Bray soil test phosphorus measurement in Wisconsin. So I don't know how it relates to what you're using out east. But these are all all of these soil test categories would be what we consider extremely high for phosphorus, right? These fields are saturated, or not, well, they're probably not saturated, but these are not in a responsive range. There's these are non-limiting phosphorus conditions. And in this case, very, very high, probably probably this one is 3 times as high as it would need to be for plant growth. So what we're seeing is when we look at the flow-weighted concentrations, we're seeing quite a bit of flow-weighted concentration. We look at when we think about phosphorus, it's not as meaningful in terms of that the losses aren't necessarily economically meaningful, right? We're only losing, sorry, I left it in kilograms per acre, but that's roughly pounds per acre. So really we're losing about a pound of phosphorus per acre per year, right? So that's not, no one's going to lose any sleep from an economic perspective. But the concentration in the water is what's problematic, or can be problematic, I should say. The threshold that we like to see under for water bodies is 0.1 milligram per liter or part per million. The concentration in the average concentration in the drainage water far exceeds that. 5 to 13 times greater than that. Now, granted, this is concentrated phosphorus water that's flowing into a water body that is relatively dilute in phosphorus. So it's not causing necessarily the water itself to go up, but if enough fields are contributing to surface waters, then it can start to influence that overall concentration. So the other thing to think about here is that if we're primarily focused on reducing phosphorus losses from surface water or surface runoff, and we're implementing management practices to do that, and we're not accounting for, if we're not trying to reduce phosphorus losses from our tile drains, and it's a watershed like these where heavy clay soils, a lot of manure, tile drain, high phosphorus flowing into the surface waters, we're missing out on a big chunk. So we may not be seeing big gains in water quality if we're not addressing both mechanisms. And what's interesting is that we saw this really neat relationship between so we still are seeing more phosphorus in the surface relative to the tile drain in terms of concentration, but the relationship was pretty tight. And so about whatever the concentration was in whatever the phosphorus concentration was in the surface water, it was roughly about a third of that in the tile drainage water. So we have this, kind of relationship to think about, where it's still most of the phosphorus is coming from the surface, but it's a good chunk of it is still coming from, a good overall chunk of it is still coming from the tile drain. And then this is just to show that our losses, our really high concentrations, are somewhat unique in the literature. And I think it's a lot of the really high concentrations and losses are connected to our use of tile, either both manure and the fact that we have high soil test levels. And so for manure applications, it's not always manure application, which is interesting. And so like we have this scenario here. This is the field that received manure every other year. So in the first year, you're going to see this first on the left here, this arrow. This is when manure was applied. And then we're looking at, in the blue here, this is the tile drain, the phosphorus concentrations in the tile drain. See, nothing, not a big spike at all. But then we look at the second manure application 2 years later, manure was applied and boom, we see spikes in both surface and tile phosphorus concentrations in that scenario. So it's not, so clearly it's not just the fact that manure is applied. It's related to, you can look here, manure is applied. These are the rainfall events, not a lot of rain, but we had a manure application here followed almost immediately by a rainfall event that's flushing stuff out. So that relationship between rainfall, watching the weather, soil conditions, and that manure application, not only affects nitrogen where you can have huge losses, but also phosphorus losses as well into the tile drain. And then lastly, we also think that this idea of this, what we call the saturated macropore theory, meaning that, we have these cracks in the soil. And so those cracks also, you can think about the lining of the cracks. And those are going to be relatively rich in phosphorus. And so not only does manure flow through the cracks, it also deposits phosphorus along the cracks. So every time water starts to flow through there as well, it can also be picking up some phosphorus from those cracks as well. So it's not just the immediate effect; it also can be kind of this, we'll call a legacy effect on these soils that have a lot of porous flow patterns. All right. So what are my take-home messages? I would say read our Wisconsin Extension pubs on tile drains. Here's our fact sheets. Although I'm sure Heather and many others in Vermont have other excellent resources for you. But they're good reads. Here's also the message that I want to leave you with, is that you really can't prevent losses of nitrogen phosphorus. If you have tile drains, if we have agricultural systems, we have losses, right? You can only set yourself up to minimize as best you can. And so, we make the case where, when we lost 100 pounds of nitrogen, we weren't setting ourselves up to minimize it as best we could in that scenario. So the key things are: know your tile drainage system and maintain it. Think about how you're applying liquid manure relative to soil conditions, and apply appropriate rates of manure, especially for phosphorus, and try to manage your soil test P levels. So, in our situations, we have very high soil test phosphorus levels. If we have a lot of manure, it's tough to try to draw those down, but that will be helpful as well. So we've got two other things where I didn't even talk about cover crops. Cover crops are hugely beneficial to reducing nitrate losses in tile drains. We have a lot of corn silage in Wisconsin. The cover crops work wonderful in these following corn silage, and they take up a lot of nitrogen, especially when manure is applied in the fall as well. You have to ask me back another time to go into all detail on that, but I highly recommend the use of cover crops for various reasons after corn silage. It's often a win-win. And then we didn't even talk about fancy drainage engineering. So there's all these technologies that you can invest in to control the drainage or try to reduce those losses. And the engineering solutions are real. I'm not an engineer. I'm a soil scientist and agronomist. And so I'm focusing mostly on the management effects, the things that we can control as we're managing our crops and soils. But if those aren't working, then we do need to go to these engineering solutions. So I'll leave you, that's up to everyone to decide on how much they want to invest in that, or what's their trade-off between changes in their management or investment in engineering. I've rambled on too long. I'm sorry, Heather.
No, it's great. It was very informative and very helpful. Thank you very much.
So I don't know if anyone has any questions, but I'm happy to.
Yeah, so we have accumulated a few questions. If folks have questions, please type them into the chat box now. We have about 10 minutes left, or in the Q&A box, and I'll get those, we'll start answering those. I am gonna put up the quick poll, so if folks can take a few minutes to answer the questions. Again, we're trying to figure out what you're learning from the webinar series. And certainly, as we go through the series, if folks want to learn more about a certain topic, let us know that as well in the chat box so we can continue this education. I think a lot of folks have heard or know that there will be new regulatory requirements coming out relatively soon focused on tile management. So that's part of the reason we're doing these presentations, Matt, because a lot of the things you were talking about, folks are already doing, but there's some new regulations that will require even more in fields that are tile drained. So some of the questions, let's see, I'm gonna go back here. Some folks were asking about, has the tile Has tile drainage mapping been performed in Iowa and Wisconsin? You had a really nice graph there, and people were kind of wondering how you did that.
Yeah. The map where where I showed it on a county basis.
Yeah.
Yeah, so that was from the 2012 Ag Census had a question about if farm fields were tile drained or not, and so we just made a special request to the USDA to ask for the data, and they gave it to us, and so we mapped that up.
Oh.
And so I'm happy to share that map. We also have on our Discover Farms website. We use that information we focus on Wisconsin, but we made a map. We've got a extension pub on the extended tile drainage in Wisconsin that shows the estimates.
Oh, okay.
And then that has those other fields as well. But I mean, there are counties in what we call the I states, Indiana, Iowa, Illinois. I mean, 90-95% of the ag land is tile drained. I think the assumption is most of that land is tile drained in those.
Okay. Yeah. Well, yeah, folks are asking for tile to be mapped in the state. So I think there is some interest in if it was actually mapped or not.
Yeah, well, so it wasn't actually mapped. It was just survey, right? So
Right.
That'll be, right. I don't know. I don't know how, yeah. There's ways to do it, but it's an investment, right?
Yeah, well, that's definitely
a lot of acres to fly over. You have to do it through imagery.
Right. So one of the other questions was in the study where you were looking at those fields that had manure application, was the manure applied, or did the, well, it says here, do these farms apply their nitrogen in the fall?
So yes. So some of these farms apply their manure in the fall, and that's obviously a very and it's a pretty common practice. Interestingly, one of the farms we worked with had a lot of little applications of manure through the fall and through the spring. But I would say that just in general in Wisconsin, in that part of the state, we've got a lot of corn silage. So there's a lot of manure that goes out in the fall, and just with all the CAFOs in that region. So we do see a lot of fall manure applications on these tile drain soils. We don't see as much of inorganic, like we don't have as much fall anhydrous in that region. So usually it's manure followed up by an in-season application of like UAN or urea, depending on if they need to top it off.
Mm-hmm.
But that's where all these other things come into play with nitrification inhibitors and use of cover crops in the fall, where it's huge risk of loss.
Yeah. Well, we definitely have good cover crop adoption in Vermont, and it grows every year. So
awesome.
It's exciting to hear that makes a difference. So somebody asked, were all the fields that were monitored high? Did they all have high soil test P? Were there any that were low? And was the study kind of looking at the worst case scenarios?
So I would say that's a good question. So we don't have a lot of low, in this region. So I mean, it's in our dairy producing regions, soil test P is crept up. So I would say these are pretty common scenarios. The grazed pasture was kind of unique because it was tiled and then it was converted back into a grazed pasture land. So, but we saw a lot of phosphorus coming out of that, but not as much nitrogen, interestingly. But and that had the highest. But 50, 80 part per million of Bray P isn't uncommon in historically manured fields.
Wow.
Yeah.
Sorry. So we do have fields in Vermont that are considered, excessive. But overall, most farms aren't in too bad of a shape. So that makes us feel better. Thanks, Matt.
Well, I mean, yeah, it's intensity of management, especially
That's
around
true.
yeah.
Yeah. So there's a question here. It says, it looks as though Wisconsin uses 10 parts per billion, I'm assuming phosphorus, as the eutrophication threshold, but does that correlate to surface water standards? In Vermont, our standard for low flow TP concentration is 27 parts per billion for streams in my area.
So 27, I'm going to make me do math, right? 27
Yeah.
part per billion, 3. So 0.027, what I use, 0.1. Yeah, you know, those thresholds, you know, I was using that. I think I got that numbers from an EPA number. I think that number is highly debatable, right? So, I mean, I get why
Yeah.
other places may want to make it higher or lower. And then is it the concentration in the stream itself, or the concentration in the outflow? You know, what's being regulated, or what's the ultimate effect, right? I mean, you can have a high concentration flow going into a watershed, but it may not be affecting the overall water quality of the watershed, right? So,
Right.
So is the rule related to the outflow of a drain, or are they considering things that are greater than 27 part per billion
Yeah.
in the water as impaired? That I don't know.
Yeah. Well, it definitely seems like it's, we're doing a lot of tile monitoring and trying to figure out, you know, what's good, what's bad, what's excessive. It seems like there's not a lot of guidance there.
And then phosphorus is tricky on the, you know, the nitrate standard, right, is based on a human health standard. And even that you can have some debate about that. And then the phosphorus is sort of this ecological standard, right? So
Right.
it's I don't know. There's more debate on it, on what the number is, or
Right.
less conclusion on what the actual number is.
Right. One last question here. If you have any more questions, please type them in. We have a few more minutes left. Are there any BMPs for positioning tile drain outflows?
So in terms of, I guess, you know, the topography of the field is going to direct where the drains should be, you know, installed to maximize the efficiency of water removal. The main thing is having enough space between where the tile drain comes out and what it's flowing into, right? So to make sure that there's enough of a drop off. So a lot of times, if in periods of high rainfall events, you can get the flow may not occur because the drainage ditch fills up, and so if it's flowing into the drainage ditch, it may not be able to flow out as well. So having enough space between that, if possible, is really the main factor. And just in a spot where it's accessible and you're able to, you know, get in there, and if some repair needs to be done. Not sure if that answers that question, but that would be the bigger issue, I think.
Okay. All right, everybody. Well, we got one more question here. Since the Vermont Agency of Ag Foods and Markets will be prohibiting air vents in new installations, will more tile blowouts result? Are there construction options to air vents? I'm not sure, Matt, if you know that, but.
I don't. We're gonna have to find an engineer to help us with that.
Great. Well, we'll see.
They're not allowing it at all, or are there rules about the placement of it?
Nope. I think they're being prohibited. So
there must be some design changes that could accommodate that then. But
I would imagine.
Yeah, we're gonna need an engineer to help us.
That's right. All right. Sorry, Kent, we couldn't answer that question. We'll get back to you on that one. Great. Well, it looks like we're out of time. And Matt, thank you very much. Thanks for taking time out of your day. And hopefully the sun is starting to shine in Wisconsin these days.
It is a little bit.
Good. Well, it is here in Vermont too. We've had our first snows, and it's definitely cooling down. Winter's on its way.
We just wanted to stop raining long enough we can finish getting all of our corn harvested.
There was a big thing on NPR this morning in Iowa talking about the rain as well as other crop issues.
It is a crazy year.
Yeah. I know. Okay, well, thanks a lot. And Matt will send you the results of the quick polls if that's helpful for you. And thanks again. We'll
You bet.
see you in Baltimore next week or a couple weeks.
I'm going to San Diego.
Oh yeah, everybody is. Okay. All right. Thanks again. Bye, everybody.
Bye.